So hello everyone, welcome to Architect Learning. So today I'm going to perform one of the lab that is manage Terraform State in partner.skills.google.com. Okay, so let's click start. Okay, so we know what is the Terraform dot state tf dot state file. So let me open it private window console. Share it. Okay, so but let's brief it still our. Okay, we got our dashboard. So this state file, let's overview. Okay, so Terraform must store the state about your managed infrastructure and configuration. The state is used by Terraform to map the real world resource to your configuration, keep track of metadata, and then to improve the performance of your infrastructure. So in local, we have terraform.state tf state, but we can also store it remote level. That is like maybe GitHub or maybe Google Cloud Storage bucket, right? So we can use that as. So what are the objectives? Create a local. First, we will create a local backend. Then we will make the state file to this cloud storage backend, refresh your Terraform state, import a Terraform configuration, and manage the import configuration with Terraform. Okay, so let's go with the lab. I will activate the Cloud Shell. Okay, so before it's going, let's check once again. See, Terraform use this local state to create plans and make changes to your infrastructure. So this is very important. Local state file is used to make plan and make changes in your infrastructure. Before any operation, Terraform does a refresh to update the state with the real infrastructure. So any operation, it will just refresh your state file as well. So the primary purpose, state file to store binding between the object in the remote system and resource instance declared in your configuration. It acts as a binding connectivity, right? Okay, so let me open it now. I will open a new terminal. So yeah, we can verify that. So you can go through it to get more information on that, how, what is the state. So some of the benefits of backends. So backends means storing at the, use the local backend, but if you are storing in the in remote level, right? So backends can store that state remotely and protect the state file with logs to prevent corruption. So if you store your state file in the remotely, so you can also lock it. So if anyone want to make change, they will get error. They will not able to change it. Okay, keeping sensitive information off disk. Okay, so only stored in memory. State is retrieved from the backends on demand and only stored in memory. Performing remote operation. The large infrastructure of certain changes and Terraform apply can take a long time. Some backends support remote operation, which enables the operation to execute remotely. You can turn off your computer and the operation will still complete. Right. In local, you need to on your computer, but if you're doing remotely, so there's no need. Just you can, it's the if connectivity is good, so it will automatically perform that one. Right. So that's good. Okay. Yeah, we are in good. And we are already in project ID, so that's fine. So first thing, I have to enable the service that is Google Gemini service, right? API. I need to enable API. I will open editor as well. Okay. So we need to perform this activity. Okay. So I will do that. First, click setting. Then in setting, you have to click Gemini. Google Assistant enable. That's fine. Now select the project. There's no, it shows no project, right? So we have to select our project ID. This is our project. So that's it. So add a local backend. So first we need to create main.t. I will create this directory. We need to open the directory. Okay, so main.tfstate file we got. And in that main file, we need to, first we are going to create the cloud storage bucket resource in the main.tf configuration. Okay, okay, so I will just edit it. What we have to do, we have to replace in as per the, we have to replace our project ID. It on the main.tf file. So this is my project. This is the region. This is the resource I need to create. That is Google Cloud Storage bucket name. This is the bucket name. I have given the project ID as the name. This is the metadata. Okay, that's fine. Save it. It will automatically no need to save. And then in the Gemini code assistance. So here it shows in the, we need to go with the main. What is trying in this prompt, what they have given, update the main.tf configuration file with the following changes. Google provided block set the project to, see that we already have done. Okay, we just manually done it. They are using the, yes, what we called Gemini Assist. Okay, so no need, we can ignore this one. Update the bucket to Q slab. That's we have done. Not okay. So you can see it's same. Now add a local backup in the TF file. So this is this one we need to copy and we need to add here. What we are doing, we are adding a local backend to your main.tf. This reference to TF Terraform test file in the terraform.state directory to specify to change the path variable. So in the Terraform directory, it will create the local this terraform.tf state file. Locally, we at first create. Okay, so let's init this. So let's initialize. Okay, we have initialization done. Then apply. What it shows, so once done run the following command to apply this as a hand enter. So you will see the Terraform state file. If you want to validate, you can validate. Okay, spelling mistake. So validate means we are validating our configuration is correct or not. Okay, and then we need to plan. We can try plan, but we can as per Without also we can go. Let's go with apply directly. Click yes. So it's, you can see, creating a template. It's created the storage bucket. That's good. If you want to examine your state file, right? So here you can see terraform.state file is created. If you want to see from terminal level, Terraform show. It will also show the state file. See, these are the changes happen. What is done? It's created this resource times of, okay. Now add a cloud storage backend. Currently it's local. We have okay. So now we need to uh, backend. See what we have to go to the main. We will now replace the current local backend with the GCP with a GCP backend. So to change the local, copy the following conversion, put it in the replacing backend. So just now we are currently it is in the local, the terraform.state file is in the local storage. So now we are moving it to the bucket, correct? And where we need to make change, we need to go to the main.tf, and here you can see, right, terraform backend local, and we are given this path. So we will delete this one and copy paste it. So terraform is backend is a GCS, Google Component Storage. This is my bucket name and this Terraform prefix. Under the Terraform, it should have the state. So now we need to run the following to initial backend again. This time automatically migrate the state file. So let's migrate it. Sorry, start state. Okay, migrate hyphen state. Hit enter. Is there any mistake? Here no hyphen is needed. Here only hyphen needed. So you can see a Terraform directory that the backend type can changes from the local to state. If you want to see pre-existing state was filed by previous local backend to the newly configured GCS. No existing state found in the newly configured GCS. So do you want to copy this state to the new GCS backend? Inherit? Yes. So what it will do, it will copy the this state file to the storage. Okay. If you want to see on the console level, so go to the storage. Where it went, send to the voice IQ. Oh, my mistake. Go to the bucket directly. This is cited. So we will see our bucket name inside our bucket. We should have our Terraform state under the Terraform state. You can see default.state file. We got it right. So this command, Terraform state command, is used to reconcile the state. Terraform knows about VI state file with the real world configuration. This is used to detect any drift from the last known state to the update state. So by refreshing it, if you made any changes on the current state file, or you can verify the difference. I mean, see, this doesn't modify the infrastructure, but it does modify the state file. Whatever the changes on the existing infrastructure, it will modify in the state file, but it will not change on the infrastructure level. Okay. So What it shows. So return to the cloud bucket, select the checkbox next to the bucket name, click label, label equal to, see if you are adding at the console level, right? So what we are going to do, we are clicking the, just we are going to the bucket, select it, give label. So key one is true, that's one fine. We need to give key two, key two is equal to key, that's a value. That's it. What we are going, we are giving, we are just labeling the our bucket. Now click save. So what we have changes at the console level, but at the Terraform state file, it is the same, right? So we need to refresh it. What it will do, whatever the changes we have done, it will update on the state file. So let me show you. We will go here. See what is showing. Declaring the state log, refreshing states. Okay. Now Terraform show. See what it shows. If you see here, we are given this value, right? So it's got updated on the TF state file. See, go Google storage bucket, test bucket, and Terraform state for state. You can see here. Okay, so that's good. Now check the progress. Okay, that's good. Now, before continuing the next, we need to destroy our provisional infrastructure. First, revert back to the backend to local. So you can delete the storage bucket and copy, replace the GS configuration with the following. So we now again we are making we are cop we are making the backend to the local from which is currently from the from the Google Cloud storage. So I will go here, I will copy this, I will go here and just paste. Then we need to click Terraform initiate and we can copy it. See, yes. So let's see in the current TF state what tag we have given. Label. Okay, previously it was true. Right, so it is show anything. It's a local. Okay, so that's fine. Now, in the main configuration, paste the following prompt. What is the configuration? Resource bucket in the main file. Add force destroy equal true in this configuration. So nothing. We need to go to this one that we can do manually as well. So Bukul, we can copy here. See, it will do the same thing, right? So if you want to verify, let me show you. What it shows, we need to go with the Gemini. We need to copy this one prompt in the Gemini. I will paste here and hit enter. What it is going to say, We're just adding that line. So we have done it manual as well, right? So I said, okay, apply. Oh, sorry, by mistake it got update. So yeah, we can do now again. I will initiate first once, then Terraform, apply. Make sure you need always plan and then go with the apply if you are working in organization. For the lab, I'm directly going with the apply, but it's always good to practice initiate, and after initiate you need to validate also good, and then you need to go with the plan, see what are the changes is going to be happen, and then apply it. Okay. So yeah, we already have completed this lab within within 20 minutes, so that's fine. So yeah, we can apply it. We have successfully applied. Now we need to destroy. Okay, so we are destroying our resource, that is bucket. Now task to import a Terraform configuration. In this, you are import an existing Docker container and image an empty Terraform workflows. By doing this, you learn strategies instead of importing real world infrastructure into Terraform. So writing a Terraform configuration, the defines structure you want to create, review the Terraform plan to ensure the configuration result will be expected in expected state and install session, and apply the configuration to create Terraform state and infrastructure. Write config, plan, apply. So after you create infrastructure with the Terraform, you can update the configuration, uh, plan, apply, and those changes. Eventually use Terraform to destroy this. This is no longer needed. This workflow assumes that Terraform will create an entirely new infrastructure. However, you may need to manage infrastructure that was not created by Terraform. Terraform imports solve this problem by loading supported resource in your Terraform workspace. The import command. So that we will see later on. We have one more lab importing existing infrastructure to the Terraform, that also we will do on our challenge lab. Okay. Bring the existing under the controversial, identify the existing, import the infrastructure in your Terraform, write a configuration. It's fine. So this one is another lab we can try. Run the following and okay, let's try. This is the Docker, create a Docker container. Let's try this one as well. So in this section, first you will create Docker container with the Docker CLI. Next, you will import it into your Terraform workplace. Then you will update the container configuration using the Terraform before finally destroy it when you are done. So we are going to use Docker container and we are going to import it. Once we create, then we import it into the our Terraform, and we will make some changes using Terraform. Okay, in that Docker container, and then finally we have destroyed. Importing infrastructure manipulates Terraform state in that could leave existing Terraform projects in valid state. Make a backup of your terraform.tfstate and terraform.directory before using the Terraform import of your real project. Yes. Always, if you are importing somewhere, make sure you need to take the backup of your tf.state and .tf Terraform directory, everything. Okay. So you will not lose anything if anything corruption happens, so you will be safe. Okay, so let's create the Docker once. Docker run resides in. Okay, let's see. After a long time, I'm working on Docker now. Okay, it's completed. To verify the container status PS. Yeah, it's running our container ID. This is the image. Nginx is image. Command 9 seconds support. Mem/coplon. Okay. So in the cloud shell, click web review and click on the preview on port 8080. Okay. where it shows Cloud Shell. Mm, Preview on. Okay, here it we have on the top corner. You can see right here web preview near to the crowd terminal. This is the web preview we need to click. Okay, so that's good. It shows welcome to our Nginx. So the Docker container is as Nginx service running. That's fine. Now run the following command to clone the example. Uh, just 1 second. Okay, I hope it's charging. Yeah, that's fine. So what we are going to clone the repository. Okay, so I will go here, just copy and paste. Hit enter. Okay, cloning has done. Enter into the directory. Then update the provider version in the Terraform directory. So see, we are updating the Terraform version. Let's see. Hmm, okay, done. That also done. This can directly contain two Terraform configuration files that make up the configuration user main.tf, docker.tf. Yes, you want to see here, we can check here. Okay, docker.tf and main.tf. Yes, we have two files. Mm, so main.tf files configure the Docker providers, and docker.tf contain the configuration necessary to manage the Docker container that curated in SL. So this is the Docker file. We have created the Nginx, right? So here it will have that. Okay, so what it shows run the to initialize the workspace. Okay, Terraform init hyphen upgrade. See, it's up. Okay. Let's install the plugins, Docker plugins. Okay, we need to comment out. Go to the main.tf, and in this provider host, we need to comment out. Yes, done. Uh, it's provide Unix Docker engine. Okay, we need to update this one now. Find the provider and resource and comment out the delete the host argument. Okay, so I have done it. Let's see. Now navigate to the lawn.docker.tf. Okay. Under the commented out code, define an empty Docker container. So it's a Docker container Docker resource ID. It's nothing, something like that. Everything is commented. In the commented out code, define an empty Docker container. Okay. So here we need to define it. Docker container web. Now try. Run the following Terraform import command to attach the existing Docker container to the docker.web. Okay, we are importing it. Okay, so let's see. Enter. Okay, import successful. Now Terraform show. Okay, that's fine. Now plan. Hmm. So yeah, it will show you the error, right? You can either accept the entire current of the stores or compression. Using the current is more faster, so you can reset overruns to engineer. For this lab purpose, you can use the current state. So copy the Terraform state in the Docker. Okay. See if you face anything error like that, just check everything first. Okay, something updated on this. Yeah, lot of update commands, everything got updated, right? Now plan. So these are the changes it will do. Now apply. Yeah. If you can remove selectively remove the optional attributes. Remove all the attributes, keeping only the required image, name, and ports. I will use this prompt. I'm not sure what are the its changes. So what I'm going to do, I will use Gemini Assist. In this, remove everything. Let's see what we get. Okay, you can see only this three is needed. I will accept. Okay, that's good. You can see the output, compare it. The name, image, Nginx. Yeah, that's fine. Now plan. Okay, so yes. Now apply. Destroying the new container. Now see. 4 seconds. New container we have created. Okay, so we have what we have done. To retrieve the image tag name, run the following. Okay, let's modify it. ID is just remove tag. Okay, we got the image. Now add the following configuration to Docker div represent this image. Okay, so that's fine. I will go to the main dot. I will use Gemini. Let's see. Just yeah, that's great. Okay, we have added the resource. Now apply again. Yes. Okay, it's created. Now the Terraform has created a resource of the image. You can refer in a container function decide to ask. To change the image to Docker container web to reference your Docker to paste the following. Update the Docker argument, Docker container resource name, file, save it as okay. Let's give this prompt. Go with the docker dot. I will use Genesis, put this prompt, hit enter. So it's updating the image. Right, click enter. Yeah, now hit apply. Yes. Okay, so we got one more container we have created. The messages since the Terraform. Okay, manage the container. For the Terraform, manage the Docker container. You can use the Terraform change. So this will be a little bit difficult to understand. You have to go through the each line. Okay, I'm just following the instruction as given, but we have already completed our task. Just we are completing this as well. So what it shows in your Docker file, change the container external to port 0028. Okay, I will go to my Docker file. Instead of TCP 81, just need to change 81. That's it, right? Okay, then apply. You see Docker PS, now it's 8081. Previously it was 8080, now it's changed to 8081. Okay, that's great. Yeah, I verified. So if we have imported the Docker container and image used to create Terraform and created into the Terraform. Now we need to uh, destroy. Run the following to validate the Docker has been destroyed. So let's see. It will destroy our container. So if you see Docker PS, what we get? See, container gone, right? So even this also will not show the same thing. So that's fine. So that's it. We have completed our lab within half an hour. Okay, so that's great. Thank you for watching and please subscribe and like this video if it's helpful for you. Thank you again. Bye. Take care.